visible, sir.
Okay,
Visual,
okay.
sir.
Okay then. So good afternoon, everyone. Today, I won't be taking up any new topic. I'll be just discussing few topic that I have sent you as recorded videos. Okay. So the first topic that I would like to discuss with you is like about this process. So if you have seen the videos, you must have the idea that what is a process, then what is a program. So we'll just go through this once again. So a program and a process are different from some point of view, right? So if we say process, then it is a program in execution, right? So you must have seen the difference also. So let me just summarize the thing from this topic, that when we say a process, it is a program in execution, and when we say program, it is just an executable file, whereas your process will contain some more information in addition to the program code. Okay, if you have just a second. So when we say process, it will contain many other parts. So it is not only the program code itself. It contains other information like your program counter, your process register. Then you'll have some memory area like stack, temporary data. Then you'll have other information. So you'll have other information in addition to the program. Okay. So, and we know that when we say process, it is an active entity, means the process is in a running state or it is in a current running part of the system. Whereas when we say a program, it is nothing but so when we say process, it is that is something in execution. Okay, it will be an active entity. So when we say program, it is a passive entity. Okay, so this is how a process may look like in the memory. So it will contain the text is nothing but your program code. Then the remaining informations are being there with the program. Okay, so it may have data, it may have mistake, other information. Means in short, a process will contain some information in addition to the program code. So here it was the difference, like what is the main difference between your process and program. So like both are mean the same thing, but the only difference is one is in execution and another one is in a idle state, in a passive state. So your program is treated as a static form of object, whereas your process is dynamic in the sense it is going to be run. So, and your program is going to be stored in the secondary storage. Okay, when we say a program, you must have done your C programming and other things. So you store it somewhere in the drive, right? When we say a process, it is running and it's being done in the main memory. Okay. Then when we say the span time of a program is unlimited, meaning that when you are when you have a program, you usually save it in the secondary storage, meaning that it's going to last long. Right? It is going to be there until you delete it. Right? Whereas your process is going time span is limited, as once the process is completed, then information is gone. Okay. So next point is like your process is an active entity, whereas your program is a passive entity. Okay. Then we have seen this one more term called thread. So a thread is nothing but what we call it as a lightweight process. It is something inside the process. It can be said a subset of a process. So it is a type of process, a small type of process. Okay, which we call it. This is the smallest unit of processing. Okay, so we have here single thread, multi-thread. Okay, so if we see the consider this is as a process, then inside process. So if you consider an idea like if you have a big task, there may be small different tasks inside the task to complete it, right? So it's just like that. When we consider the process as a big task and individual tasks inside it as a thread, so individual tasks are being done inside a single thread. So when we say single thread process, it means it is doing one thread process at a time. When we say multi-threaded process, there is going to be multiple the process going on inside it. Okay. Then this is also an important state. So when we say a process is in a state, means a process can be anywhere in this following state when we want to know about it. Okay. When we say a process is in a new state, it means that your process is just in the process of creating. So you're just if you ask in this point like what is the state of that particular process, when we say new means the process is being in the created stage. When we say running, the process is in the running state. When we say waiting, it means that the process is being idle, it is waiting for some other process to complete it and to get the CPU. Okay, ready. Then when we say ready, the process is waiting to assign to a particular processor. Okay, so like here, the process has to be in the ready state before getting the processor. Okay, so then last is terminated, as the name suggests. Once the process is completed, then we're going to terminate it, and that state of the process is called as termination or terminated state. Okay, so if you see this diagram, so this is the cycle of a process state. So the first and foremost thing is the process has to be created, right? So when the process is created, it has to be in the new state. Then once it is created, then it has to go to the ready state. Okay, once it is in the ready state, then it can go directly to running if it gets the CPU. Okay, if it gets the CPU, then only it is going to be gone to this running state. In case if the CPU is not given to it, it has to be in the waiting state. Okay, then once it is done, then it will be terminated. So what are the 4 stages that has to be compulsorily encountered by a process? Is nothing but new, ready, running, and terminated. Means when a process is executing, then it may go through this waiting state, may or may not be, but the remaining 4 stages is compulsory for any process. Okay. Then we have this process control block. Also, we call it as task control block. So here also it's going to give information about each process. So it's like process state, then process counters or process state, like whether the process is running state, waiting state, or terminated state. So all those information will be given by this control PCB, okay, process control block. So whenever we say a process, it will be associated with this block where information will be there. Then your program counter location of instruction to the next to be executed. So here the instructions are being there, so you know what has to be done next. Then it will contain about CPU registers, so content of all the registers. Then CPU scheduling information. So this CPU scheduling is an important topic. It will come in the next class. So information like priorities, scheduling queue, pointers. So like when we say here, it will give the information about whether your current process is going to be executed or not, or whether there is any other higher priority process being in running state. So it will give information about it. So then it may give information about your memory, then other information like CPU use, clock time. So it may also give you information about the input output devices also. So in short, this PCB or process control block is going to give an overall information about the process, and we can get the information about the process through this block. Okay. So then once we have that, we have some few operations. Any problem? So the next topic to see is operation on processes. So in the Google Classroom, I sent one topic before this one, but you just when you study in this order. First that slide, then study this slide. Okay. So when we say a few operations, the operation may be like process creation and process termination. So these are the operation that has to be carried out with a process, right? So it has to be created, then it has to be terminated. So in operating system, we use a system called call as fork. So it is used to create another process. So we use this fork in the Linux system. So where your process is going to be created, and the process that is being used to create another process is called as the parent process, and the process that is being the process that is used to create another process is called parent process, and the process that is being created is called as the child process. Then your parent process is going to create child processes, which in turn can create another process, forming a tree of processes, meaning that it is not necessary that a process is going to create only one process after it. So it may create process one by one and keeps going on. So it may form a tree of processes. So here, when we say creation of process, it an important parameter is nothing but this process identifier. We can write it shortly as PID. You may find it. So generally, your process is identified and managed by way of this process identifier. So every one of us has something to identify ourselves, like our name. So similarly, the process will have this identifier to name themselves. Okay. So when we have this parent and child processes, we may have different option of sharing the resources. Okay. So like the parent and child may share the resources, or the parent share subset of the child share subsets of the parent resources, meaning that it may share some part of the parent's resources, or the parent and child share no resources. So meaning that you may have different conditions or different options of sharing the resources. And when we say about the execution option, it may be executed concurrently or parent wait until child terminate. Okay, so like this may be different option of existing the process together. So this is your process creation example where, as I have mentioned before, that we may use this fork system to create a new process. Then we may use this execute system call to replace the process memory space within a new process. So in short, it's going to give some memory to the process. Then the parent process wait will call this wait operation to wait for the children to terminate. Okay. So here, if we see this diagram, whenever you create a process from the parent, so usually the process ID, your PID, process ID, okay, has to be usually denoted as 0 for the child, and for the parent is something other than 0, like integers. Okay, so if it is parent, then it's going to wait for it for the child. So once the child is terminated, then it will resume. Okay. So in short, what it says is usually your parent process can wait for the child to terminate, but it is not always the case. You may have some cases where the parents terminate itself, leaving the child, or the child terminated itself. So we'll come to that also. So when we say process termination, so your process execute last statement and then ask the operating system to delete it using exit system call. So it's nothing but your process termination using your exit system call. Okay. So here, a parent may terminate the execution of a child process using abort system call. Means in the middle of the process, it may call this if the reason may be listed as below. So if the child has exceeded allocated resources, so the given allocated resources has been exceeded by the usage by the child process, then the parent can terminate it. Or the task assigned to the child is no longer required, then also the parent can abort the process. Then the parent can even exiting, and the operating system doesn't allow a child to continue if its parents terminate. So this may be few reasons where parent can terminate the child process. So then here we have few terms like cascading termination. As the name suggests, cascading means more than one, like a series form, right? So cascading termination means termination of your child, grandchild, meaning the termination of various process level of process. Then we have two process called as, one is zombie, one is orphan. Okay, so when we say zombie, the parent is not waiting for the process, and the parents may terminate it. Okay, so the parent doesn't wait for the process to complete, and then we call that as zombie. And when the parent terminated, leaving the child in execution, then we call that process as orphan. Okay, so here also it says that when your parent is finished execution and exit while the child is still in execution and it's allowed to run, so this type of process is called as orphan process. Then we have this next topic, that is inter-process communication. As the name suggests, it means communicating among different process. Okay, so here your communication may take independently or cooperatingly. So when we say cooperating process, it may affect or may not be affect between the process. So when we go for this cooperating process, the reason may be like when we look for information sharing, computational speed up, modularity, then convenience. So this may be few reasons to go for cooperating processes. Cooperating means so they communicate among the process. So this is what we call as this uh, communicating among the process is called as the process communication. So for cooperating process, it has to go through this inter-process communication. So here there are two models of this inter-process communication. One is when we share the memory. Okay, when we share a common memory, that is one way of inter-process communication. And when instead of sharing the memory, when we share the information in the form of message, then that mode is called as message passing. Okay. So if we look over here, so here you have two processes, A and B, and they are being communicated through a shared memory. So this is one form of our inter-process communication. Then here we have two processes, A and B, but they are communicated through message. Okay, so this is another form of the communication. So here I have given an example of a inter-process communication. So here the process is called problem is called as producer consumer problem. So here this is an example of inter-process communication. So as the name suggests, here we have two processes. So the first process is called as producer, and the another process is called as consumer. Okay, so here how it works is, so as the name suggests, producer is going to produce some information, whereas the consumer, as the name suggests, is going to consume the information that is produced by the processor. Okay, so here we may have two variation on their buffering way. One is unbounded buffer. As the name suggests, your buffering limit is not there. When we say bounded, there will be a limit to it. Okay. So when we have this unbounded buffering, practically there is no limit on the size of the buffer, meaning that the producer can produce continuously without any limit, and it never waits, meaning that your producer is going to produce some information and it doesn't wait for the consumer whether it is receiving the information or not. It means the producer just does his work of producing the information without checking whether the consumer is receiving the information or not. And then for the consumer where if there is no buffer to consume, so the consumer is going to wait only in the condition if there is no production from the producer. Okay, no buffer means there is no production. So when we consider about this bounded buffer, we make assume that there is a fixed size buffer, meaning that the number of production is limited to a particular number. Okay, then your producer must wait for if all the buffer are full. This is one condition, and consumer is going to wait in the condition if there is no buffer to consume. Okay, so then as we said before that IPC, this is your share memory. I think everyone can understand when we'll see this message passing. So in this message passing, as the name suggests, we are going to have some message. When we have message, they're going to be send and receive. Okay, so it will consist of two operations, send and receive. So here the first and foremost thing is when we try to communicate by messaging, we need to have a communication link. Okay, then we are going to exchange information. So for exchanging information, it may be in the form of direct communication, and another form is indirect communication. When we say direct communication, we are going to include explicitly the sender and the message in this form. Okay, in this form, send and receive. Okay, then when we say indirectly, we are not going to include the particular process. Instead, we are going to go with a mailbox. Okay, we are going to talk about a common mailbox which have a unique ID. So if you are in that mailbox, you will receive the message. So then we have another topic, that is synchronization. Okay. So here your message passing may be blocking or non-blocking. Okay. So when we say blocking, the message that is being sent has to be blocked until the message is received. Okay, so blocking send, blocking receive. So the sender has to be blocked until the message is received. So in this manner, if you see it, the form of and the receiver is blocked until a message is available. So if we see this form of message passing, you'll say that there is a synchronization. So once the message is received, then the sender is allowed to send message, and the receiver is allowed to receive only when there is a message. So in this form of message passing, it gives a synchronization way of message passing. That's why we call blocking as synchronized synchronized message passing, whereas when we say about non-blocking as asynchronous, as look, if you the sender send the message and continue, so it doesn't require whether the message is received or not. Okay, and in the receiver side, it receive a valid message or a null message, meaning that there is an empty message. So it may consist all those things. Okay. So these are the topic that we have. I have sent in the whole classroom also. So if you have any doubt, you can raise, or if you have nothing, then you can leave your roll number in the chat box. So